So how should I put this in? 11 comma minus 11?
I think you have to do x. Actually, try that first.
Okay. All right. Now this is one that I couldn't do this way. In other words, if it has a term without the square in it, a variable like this one does, then the only way to do this one is by factoring it from the get-go.
Okay.
In other words, I don't have a choice on this one. I wouldn't be able to solve it if I took the 56 to the other side and tried to solve it that way. But I can solve it by factoring. So let's practice factoring. You can never get too much factoring practice. Get me started here.
Okay, so would it be
what's going to produce an n squared? This term times this term has to produce n squared.
so can I do 2 and 28?
Well, let's try n and n. Okay? Don't try to factor the whole thing at one go-around. Learn these steps to factoring. And the first step is breaking up that first term and writing it into the two spots. What's the second step?
Is it getting into the box?
Forget, I don't know the box method very well, so unfortunately I never use it because it's way more complicated than my method. If you're using my method, the next step is to figure out the signs. Well, what do the signs have to do that produced a negative 56?
They were subtracted.
They have to be opposite. In other words, what we're looking for here is a linear term. One of them's plus, one of them's minus. That's the second step, is to figure out the signs on these two factors.
All right.
Now, the third step is factors of 56 that subtract, because of that negative sign, to the coefficient of the middle term. Well, what is the coefficient of the middle term? 1. And not with the sign, just the coefficient, the absolute value of that coefficient, which in this case is 1. So what factors of 56 subtract to 1? Now see, here's where you really need to know your multiplication tables, because a calculator doesn't help you. The calculator won't tell you that answer. It won't tell you what factors of 56 will subtract to 1. But if you were really good on your multiplication tables, you'd recognize 8 times 7 is 56. So it's got to be 8 and 7. They subtract to 1 and multiply to 56. Now, which goes where? Well, the bigger factor always goes with the sign of the middle term. Sign of the middle term is minus, so that's where we're going to put the 8. That's where the 7 goes.
All right.
Now, what's the solution?
Negative 56.
No. In order to solve this problem right now, the only way two things can multiply together and give you 0 is if either one of them is 0. You can't multiply two numbers together and get 0 unless one of them is 0. So the way to solve it is to say, okay, so 10 plus 7 equals 0, or n minus 8 equals 0. Well, this one gives you a solution of what? N equals what?
Wait, how does n plus 7 equal 0?
Because I can say that that has to be equal to 0, because it's multiplying something else, and together they multiply to 0. So that's how I make that leap.
All right.
And it applies to this term also. So this can be 0 or this can be 0, but for sure one of them has to be 0. You give me two numbers that multiply to 0, there aren't any. unless one of them is 0.
Alright.
So that's the beauty. That's why we solve quadratics in this method of factoring them, because I can't solve that. But if I can get that being one thing times another thing, now I can set each of those things to 0, and when I set n plus 7 to 0, that means n would have to be minus 7. And when I set n minus 8 to 0, it means n has to be 8. You see where I got those two answers?
Yeah.
Okay. So that's the entire process for solving that problem by factor.
Okay.
Okay, let's do another one. Oh, we got to put in our answer, I forgot. So what was it? It was minus
n plus
7
7.
and 8. So they don't seem to care which one comes first.
You have to put this one in parentheses, I'm pretty sure. Actually, I guess go ahead and try it.
Yeah, I think this will work, to be honest.
Oh, alright.
Only because it worked on the last one, where we had to put in a positive number and a negative number. All right. Now, I know it must be tough to ask you to do this in a way that's different than the way they're teaching you in class. And sometimes I question whether or not I actually have learned the box method, but I never use it, so I never remember it. And it's extremely complicated and very confusing. So my method actually is not that confusing. If you learn my method, it'll work nicely for you. It really will. As long as they don't make you show your work and show this California method or diamond method or box method, it'll work just fine for you. So how do I begin here? What's step 1?
Define the two, or I guess you can go ahead and write in W.
Yeah, I know it's got to be W and W. That's the only thing that multiplies together to give W squared. Okay, next step. Examine the sign. What does that mean?
That both numbers are going to be positive?
No, it means both numbers have to be the same. Both signs have to be the same.
Okay.
Because minus and minus will produce a positive. Notice that when I do a minus times a minus, I'm going to get a positive. So just because that thing is plus doesn't mean they're both plus. It means they're both the same, and to figure out what they are, look to the middle term. That's how I know they're both minus.
Okay.
Okay? Now, third step. Factors of 36 that add, not subtract, add because of that plus, to the number 12. Not to minus 12, but to 12. What are factors of 36 that add to 12?
1 sec, hold on. 6 and 6?
Yeah, and that's the answer. So, what is our answer?
Is it positive 6?
Yes. In other words, we got it by solving the equation. W minus 6 has to equal 0. Well, if that's true, then W has to equal 6.
Alright.
And there were two answers. It's just that they were both the same. Ooh, it might want 6 comma 6. Let's see. No, it accepted just one answer. Okay. Hold on. Now, what is different about this problem over the others?
There's only one number.
There's no numbers. In other words, 0 is on the right side like all of them, but there's no constant being added or subtracted from these two. Well, that's huge, because what can I do here? That's not difference of perfect squares. It's not anything that I can factor like we've been factoring, but there's a greatest common factor I can take out of that. What?
9?
No. The greatest common factor has to be divisible into both terms evenly.
Oh, then 1.
How about x? Both terms are divisible by x and only x. When you divide both terms by x, you get left with this, right? In other words, if you multiply this out, don't you get x squared minus 18x?
Yeah.
So all we're doing is splitting it into two things multiplied by one another. So now what is my answers going to be?
Would it just be positive 18? Or x equals positive 18?
Well, that's one answer. Remember, either that has to be 0 or that has to be 0. I'm still multiplying two things together.
So then the other one would be x equals 0.
Correct. Okay, 3x squared equals 3x. How are you going to solve this?
1 sec.
There's a trap in this problem that's
Is it going to be
real easy to do, and it's incorrect to do. What's the very first step here?
to find the value, so it's x?
Well, I gotta solve it. But what's my first step going to be?
3x squared.
No, the first step is I'm going to subtract 3x from both sides.
Okay. Oh, so you get 0 on the right side?
Yeah, always trying to go for that 0 on the right side because that's a critical number. If that's not 0, then I can't apply that rule of algebra. In other words, that rule of algebra that says if two things are multiplied together and they're equal to 0, you can set each one equal to 0. Well, if I got two things multiplied together equal to 3 or 4, I can't solve it. If you tell me x times y is equal to 10, there's no way to solve that. You tell me x times y is equal to 0, I can solve it because I know either x is 0 or y is 0. So that's the key for putting 0 on the other side. And that's why we solve all quadratics by putting 0 on the other side, generally. Okay, so now we're back to the same thing. We've got x squared, x, but we don't have a number. What does that mean? That means we don't factor that the normal way. We factor it by taking out a greatest common factor. What is it?
3.
Well, I can certainly take a 3 out. What else? Can I take an x out?
Yeah.
Well, you need to do it. If you can do it, you got to take an x out. What's left behind?
3x, so then minus 3x?
No. First of all, take that and divide it by 3x. What do you get? What is 3x squared divided by 3x?
3.
X. Notice that division is the inverse of multiplication. So if you don't know how to do that division, try something and then make sure that that multiplied by that gives you 3x squared. That's really the way to do these problems. If you don't know how to divide something, go ahead and try it and then make sure that it's correct. In other words, if I came up with 3, well, that doesn't work. 3 times 3x is 9x. I don't see any 9x's up there. So whatever goes here has to multiply back together to give you this first term. And whatever goes over here has to multiply back together to give you that term. Well, that's minus 1. In other words, I got to divide minus 3x by 3x, and I get minus 1, right?
Yeah.
If I divide minus 3x by 3x, everything cancels except the 1. So that's why after factoring you get that. Now, make sure you look at that and you see that if I multiply that back together, I got 3x squared minus 3x. And I do. Now we're in a position to solve it. What's the solution?
So you'd have, would it be 3x squared minus
No,
3?
hold on. Either that or that. There's no longer any x squared. That was the reason we factored it, was to split it up into two terms that would only have an x to the 1 power, not squared. So what does this allow me to say? The fact that I got this multiplied by this equals 0. What does that mean? What can I say based on that?
That x equals 0?
Right. Well, 3x equals 0, which means x equals 0. Or x minus 1 equals 0, which means x equals 1. So there's two solutions, 0 and 1.
All right.
0, 1. And I think I'm going to have to end it there.
Okay.
Okay, and I want to hit save, right?
Yeah.
Okay. These are good for us to do, but we probably need to do more of them. In other words, I don't know that we had quite enough practice tonight. I think another few minutes of this and you would get it. You really would.
Yeah.
But I guess just try to go on and do some others, but try to memorize that technique I have for factoring and taking out a greatest common factor. You need to be able to do both of those things. You're not going to be able to go forward in math without being able to do both of those things. Factoring a quadratic and taking out a greatest common factor are two skills that are absolutely necessary. Okay?
All right.
All right, Tucker. I will talk to you next time.
All right. Bye.
Bye.